Penguin Random House Audio presents The Zoologist's Guide to the Galaxy. What Animals on Earth Reveal About Aliens and Ourselves by Arik Kershenbaum. Read for you by Samuel West.
1. Introduction. That life exists elsewhere in the universe seems almost inevitable. That we could know anything about it seems almost impossible. But my goal is to show you that we can actually say a great deal about what aliens must be like, how they live, and how they behave. We are increasingly confident that there is life elsewhere in the universe, and even more excitingly, that it might be possible to find it. In 2015, NASA's chief scientist, Ellen Stofan, predicted that we will have evidence of life on other planets within 20 to 30 years. Of course, she was talking about microbes or their alien equivalent, not necessarily intelligent life. But the principle is still staggering. We have gone from being obsessed with the possibility of alien life at the beginning of the 20th century to complacent pessimism in the 70s and 80s, and now back to a realistic scientific optimism. This book is about how we can use that realistic scientific approach to draw conclusions with some confidence about alien life, and intelligent alien life in particular. Short of aliens landing in New York, how can we know what they're really like? Do we need to rely on the imagination of Hollywood and of science fiction writers? Or perhaps alien animals are likely to be no more bizarre than a kangaroo hopping on giant feet, or a squid jet-propelling itself through the sea with skin that flashes in rainbow colours. Trusting in the universal laws of biology that bind us, all life on Earth, and also those creatures on alien planets, we will see that the reasons for those adaptations that animals have adopted on Earth are likely to be reasons for adaptations on other planets as well. Hopping and squirting will be perfectly reasonable ways to get around on many different planets, just as they are on Earth. How rare is life in the universe? Until the 1990s, the presence of planets around other stars, exoplanets, was a matter for speculation and some mathematical calculations. We had no solid idea how many planets there might be in the galaxy, and what they would be like, how hot, how much gravity, what atmosphere, which chemicals. As technology reached a level where it was actually possible to detect planets around other stars, excitement began to grow. Perhaps there was indeed a possibility of detecting planets that could host alien life. First indications were disappointing. The few planets discovered were large, hot, and made of gas, not very amenable to life, either as we know it or otherwise. But less than 20 years after the first exoplanet was discovered, there was a major breakthrough. The Kepler Space Telescope was launched to search for possible planets, staring at stars in just one tiny fixed region of the sky. Within just 6 weeks of Kepler beginning operations, 5 new exoplanets had been discovered. By the time Kepler ceased operating in 2018, it had discovered an unbelievable 2,662 planets around the stars in just that tiny corner of the sky, about as much as you can cover with your fist at arm's length. The implications are staggering. There are far more planets in the galaxy than we had previously thought, and with improved measurement methods, we now know more about what those planets are like. We have found the full range of planetary conditions, from hot, Jupiter-sized gas planets to those that are remarkably similar to Earth. See The Planet Factory, Exoplanets and the Search for a Second Earth by Elizabeth Tasker. The universe is now a lot more crowded than it appeared to be in 2009, and our grandchildren will likely not even believe that we once said Earth-like planets are rare. We no longer have any excuse to say that the universe lacks possible homes for alien life. We now have a much better understanding of the physical, environmental conditions that are likely to exist on alien planets, and increasingly often we can even measure them directly. New instruments being developed will be able to detect the chemicals in a planet's atmosphere by spotting changes in the light passing through the atmosphere from the star it's orbiting. We'll be looking for oxygen, of course, but also for complex chemicals that might indicate industrial development. Ironically, pollution is a sign of cosmic intelligence. Somehow, life came into existence at least once in the universe. We are proof of that. But how that happened, we don't know. There are certainly many theories on the mechanisms by which life may have arisen on Earth. Most likely the basic chemicals needed for life formed at random, and then, by a lucky chance, combined into a special kind of molecule that could make copies of itself. Overall, a fairly unlikely set of circumstances. Does that mean life on other planets arose the same way? Absolutely not. We really don't know how relevant the processes that we think took place on Earth may or may not be on other planets. Aliens may be based on carbon chemistry like ours, carbon chemistry unlike ours, or something altogether different. The principles of chemistry are pretty well understood. So many of these ideas can be tested in the lab, seeing which chemicals might be stable and which not. We think that chemicals like the ones that make up our bodies are pretty good ingredients for something that is alive. But beyond the most basic ideas of what alien biochemistry might be like, a thick fog descends. We have no examples of alien plants or alien animals to examine, nor even any idea whether the terms plants and animals would have any meaning on another planet. Despite NASA's optimism that we will discover signs of alien life, the vast distances between the stars mean that it would take a huge technological leap to visit planets outside our solar system. We can mix alien chemicals in a lab, but watching alien birds with binoculars will be a much harder proposition. One problem with understanding the nature of aliens is that our starting point for comparison is just one single type of life, that on Earth. How much can we use our single example of life to draw conclusions about other planets? Some people claim that speculation about the nature of alien life is futile, that our imagination is too tied to our own experience to be able to encompass the staggeringly diverse and unfamiliar possibilities that may be reality on other worlds. The science fiction writer and author of 2001: A Space Odyssey, Arthur C. Clarke, said, "Nowhere in space will we rest our eyes upon the familiar shapes of trees and plants, or any of the animals that share our world." It's a popular belief that alien life is too alien to imagine. I don't agree. Science has given us the opportunity to move beyond such a pessimistic outlook, and we do seem to be able to identify some clues about what alien life might be like. This book is about using our understanding of how life works, and most importantly, how life evolves, to understand how life will be on other planets. How did an earth-bound zoologist like myself, who is more used to following wolves over the snows of the Rocky Mountains or tracking furry hyraxes in the hills of Galilee, get involved in the search for extraterrestrial life? One of the things I study is animal communication, and why animals make the sounds that they do. In 2014, I gave a talk at the Radcliffe Institute in Harvard entitled, "If Birds Could Talk, Would We Notice?" It may seem obvious to us that humans have language and other animals do not. But how do we know for sure that is the case? I was looking for mathematical fingerprints of language in the communication of animals, a clear-cut measurement that would say, yes, this is language, or no, this is not language. With the encouragement of some good but somewhat eccentric colleagues, the obvious next step was to ask the same question about signals from outer space. Is this a language? If so, what kind of creatures might have produced it? From there, it becomes clear that we can extend our understanding of other aspects of life on Earth, finding food, reproducing, competing and cooperating with others, to alien planets as well. But why study aliens in the context of zoology when we haven't seen any aliens and don't even know for sure whether they exist? When undergraduate students arrive at university, fresh from school and from exams that rigorously tested their ability to remember a long list of facts, our first job as their educators is to convince them that facts are all very well, but that they must understand concepts, not what happens in the natural world, but why.
Sample complete. Ready to continue?